Fortinet's IPS signatures are rules that allow for identification of network packets associated with normal application traffic, as well as that corresponding to attempts to attack the network and exploit software vulnerabilities. Signatures created for the intrusion prevention system enable you to monitor application traffic, to control or limit application behavior, and to log and block penetration attempts. 3 examples are presented in this video to introduce IPS signature syntax. More detailed treatment of the IPS signature syntax is available in the accompanying PDF Guide to Signature Syntax. Our first signature will allow you to monitor remote desktop protocol brute force login attempts. The Microsoft RDP client connection uses TCP port 3389 with the X224 protocol, so we'll create a signature matching for these criteria. We begin now by specifying a signature name using the name option with the value ms.rdp.connection.brute.force. The next option is protocol TCP. Aside from TCP, the protocol option can be paired with values such as UDP, ICMP, or numeric values based on the IPv4 header protocol field. IPS signatures can match both source port and destination port values, or ranges of values. An MS-RDP client connects on port 3389, so we add this detection criteria to the signature. TCP connections have direction, either client to server or server to client. To detect the packet flowing from the RDP client, we use the flow option with a value from client. The syntax to detect a packet's sequence number allows matching for a single packet or a range of packets. The MS-RDP connection is initiated in the first packet sent following the TCP handshake. To detect the first packet, we write sequence value 1 along with keyword relative to signify this value is an offset rather than an absolute number. The pattern option can be given both text and hexadecimal string values, which are surrounded by double quotes, with hex values bracketed by vertical pipes. Our analysis indicates that the 6th byte of the first packet's payload is the hex value E0. So we use this with the pattern option along with distance and within specifications to indicate the precise position where this pattern must occur. To test the frequency of matching, the rate keyword is used with parameters for count and duration. These parameters allow you to vary the detection frequency threshold. We'll assign a count of 200, occurring within a duration of 10 seconds. A track source IP criteria specifies that matching be limited to packets all originating from the same IP address. Other track option values include destination IP as well as MAC address. IPS signatures are prefixed with a type header, written F-SBID. Okay, so we are finished with authoring an IPS signature, and now it's time to add it into the FortiGate. Here we are in the FortiGate interface. First, go to the Security Profiles tab, and you see IPS signatures. We'll click Create New. I'm going to copy and paste, grabbing the name here. Also, I'm going to add a 2 at the end because there is an existing signature already with the same name. Pasting in, click OK. There's the signature, and we go to the sensors, choose IPS demo sensor, which I'd already created. Create new, select specify signatures, and find that signature, select it, and we're going to monitor this signature. Click OK. To activate it, go to the policy section and choose the interface. I'm choosing internal to WAN 1. Scroll down and turn on the IPS module, IPS security profile, select IPS demo sensor, and OK. Now, under the log and report section, you'll be able to see hits on this signature. Snapchat is a popular application for sharing text and photos. In our second example, we'll create an application control signature for a Snapchat login. We've specified name, protocol, and now add a service option with service type HTTP. Many other service types are supported. The parsed type option can accept HTTP GET and HTTP POST values. Here we want POST. Here are the other supported values for the parse type option. Next, we'll add pattern strings for the host, URI, and user agent. OK, again we prefix with f-sbid and enclose in parentheses. Let's go to Security Profiles, create a new signature, copy and paste Snapchat login. Click OK. Go to the sensor, select IPS demo sensor, or whichever you've created. Create new, specify signatures, and select the signature. This time we select block, and OK. Again, verify that the policy is active for the desired interface. We see that it is. And this will achieve application control for Snapchat login. Our last example considers a publicly disclosed SAP NetWeaver software vulnerability. We will use not one but two signatures in this case. The tag option allows you to define criteria that span multiple packets. Here's the general format. Use tag set to mark a session with a named tag, and tag test to check if a tag has been set. The two signatures we're creating use options similar to preceding examples, including name, protocol, service, destination port, flow direction, as well as pattern strings with context and distance options. Now we add the tag set option and a tag name string to the first signature. Then the tag test option with the same tag name string to the second. This combination establishes two conditions that must both be met to trigger detection. The tag quiet option is used to suppress logging and is normally included following tag set. Again, we prefix with f-sbid and enclose in parentheses. Let's enter the SAP signatures into the FortiGate. We go to IPS Signatures, create new. I'm going to cheat a little compared to what I showed you initially. Custom signatures may not have the same name. So I've appended a 1 and a 2 to the tag set and tag test signatures for SAP. Go to the Sensors, select IPS Demo Sensor, create new, select Specify Signatures. First we select SAP Example 1. This is the tag set. We select Monitor All. Create new, specify signatures, SAP Example 2, and select Block. Here's SAP Example 1 set to Monitor and SAP Example 2 set to Block. Go to the desired interface under Policy and verify that the IPS demo sensor is on.